everyone. Thanks for coming out. My name is Lauren McGrath. I am the director of the Watershed Protection Program here at Willistown Conservation Trust. And I'm so excited that you all are here with us today in the lovely Rushton Conservation Center. So quick show of hands, how many folks are fly fisher people? Oh, this warms my heart. This is fantastic. Great. Anyone else real fishermen? All right. Well, great. I'm not. So I'm very excited today to be if I can get my slides to advance. There we go. To be joined by some folks who know what they're talking about in the realm of fishes. So Dr. David Keller is here, if you want to raise your hand. He's going to be speaking today. He is the head of the fisheries section at the Academy of Natural Sciences of Drexel University. And Dr. John Jackson is here from Stroudwater Research Center, where he's a senior scientist. So I'd like to officially welcome everyone to Willistown Conservation Trust. We are a land trust, but we're working on creating meaningful connections to the landscape through a variety of program areas. So for us tonight, that means through watershed protection and engagement with our waterways. But we also have an agroecology program. You may have walked across a dormant farm. Seeds are starting in our greenhouse. We also have a bird conservation program and an active stewardship program. So if you'd like to learn more or how to get involved, we have plenty of literature out, and you can visit our website at wctrust.org. So I'd like to give a brief land acknowledgement to the stewardship that existed here before Europeans. Willistown Conservation Trust program area exists on the ancestral homeland of the Lenape Nation, and we're grateful for all of that stewardship that existed. And we're working on understanding and incorporating traditional ecological knowledge into our work so we can move forward sustainably into the future. And quick PSA before I get into the heart of our work. You may have heard about a new invasive species in the region, the New Zealand mud snail. If you haven't, this tiny snail has been found in a number of nearby waterways. And seeing as we're a group of anglers tonight, I would really advocate for inspecting and cleaning all of your gear anytime you're leaving a waterway, and sterilizing your equipment by letting it dry completely before moving between waterways. Check everything really closely, particularly if you have lace-up boots or felt-soled boots, because these snails are only slightly larger than sands, and it only takes one. They reproduce asexually, so it's a real treat to have in our region. But if you do happen to spot any or suspect that you've spotted some, you should contact the PA Fish and Boat Commission. And if you're in the Ridley, Crum, or Darby Creeks, feel free to give us a call too, so we can keep an eye out and continue to spread awareness around this new non-native snail. So there's your PSA for the day. All right, so this is my favorite map. This is the country of the United States of America as seen from a watershed perspective. Today, our discussion is all about how our land use is influencing our water quality. And I love looking at the Mississippi River Basin because it really drives home the fact that our entire continent is connected. So activities in Western Pennsylvania have the potential of influencing the Gulf of Mexico. So when we're thinking about our work on the landscape or how we're active in the waterways, I encourage you to start thinking from a watershed perspective. What's happening downstream of where you are, and how can your behaviors positively or negatively be impacting life, human or non-human, downstream? To bring it closer to home, we are currently in the Delaware River watershed. And my program studies the headwaters of the Ridley, Crum, and Darby Creeks. So when we're looking at our waterways, it's important to know where you are, right? Because it's going to influence the wildlife that you're seeing, what's happening in the waterways, but it also gives you the potential to be influencing things downstream. And in the Delaware River, this is really critical because the Delaware provides drinking water for over 13 million people from New York, New Jersey, Pennsylvania, and the state of Delaware. So we want to be cognizant of that as we're active in our waterways. So to zoom in a little bit, we are currently sitting in the Ridley Creek watershed, and we're just to the west of Philadelphia, and our program area is Ridley, Crum, and Darby Creeks. So to refine that a little further, I've said a couple of times now that we're studying these waterways, and that means that we are visiting 10 sites in the headwaters of Ridley, Crum, and Darby every 4 weeks and looking at water chemistry, seeing what's happening in that moment in the waterway. And then once a year, we go out and look at all of the bugs. So I said I'm not a fish person because I'm a bug person. Don't hold it against me. We have 5 sample sites in Ridley Creek, 4 sample sites in Crum Creek, and 1 site in the Darby Creek watershed. And I fully respect that 1 site doesn't give you a ton of information. So in the Darby watershed, we're actually partnered with the Darby Creek Valley Watershed Association with support from Stroud Water Research Center, running a community science monitoring program. Every 4 weeks, we now have 30 volunteers at over 25 sites who go out and collect data for us. So I'm not going to be talking about that program today, but if you'd like to learn more, please feel free to talk to myself or Anna Willig, who is my counterpart in the watershed program, to learn more. All right, so when we're talking water, it's really important to make the connection between our landscape and what's happening in our waterways. So there's a lot happening in this map. And you can see, basically the breakdown is we have fairly comparable land use between all of our 10 sample sites. And I want to draw your attention to the percentages across the top of this figure. That is the percentage of impervious surface within each of these watersheds. So our highest percentages exist in the Darby Creek watershed at Waterloo Mills Preserve. That's at 20.6% impervious. And the West Branch Ridley Creek, which is sitting at a cool 20% impervious. And so an impervious surface is any surface on the landscape that water hits but cannot penetrate through. So things like driveways, asphalt, roadways, rooftops. And our least impervious site is West Branch Crum Creek, which is at less than 10%, it's 9.91%. So that's pretty good, right? Except when we think about the context of our sensitive species like brook trout, Pennsylvania's only native trout species, and a lot of our insects and invertebrates like freshwater mussels can actually start showing signs of decrease in population at anything over 5% impervious surface. So we're already starting our conversation knowing that we have some impact from the landscape. And John Jackson's going to be talking about this a little more in depth in a few minutes. All of this together is compounded by the 2022 report from the PADEP that shows that about 1/3 of all Pennsylvania streams are considered impaired. And an impairment means that it's not functioning at the level to support sensitive organisms or particular types of recreation. So when you have a state with almost 86,000 miles of stream, 28,000 miles of impairment is a pretty big lift. But it's important to know that these streams exist. And it's also important to note that all of Darby Creek, with a few small tributaries excluded, is considered impaired, and portions of Ridley and Crum Creek are already considered impaired. So we know this as our baseline going into understanding what's happening in our waterways. Once impaired, that does not mean permanently impaired too, which is an important note. All right, so now I'm going to get into some really, I think, interesting water chemistry. And we're just going to do a really quick run through. Y'all are fly fishermen. You know that temperature and dissolved oxygen are really important for fishes. And I'm going to go into a little bit more detail as to why. And then Dave's going to run through all of the incredible fish that have been seen in our waterways. So temperature and dissolved oxygen. So again, to remind you, I'm a bug person. I have a lot of pictures like this on my cell phone, more than my family, more than my friends. It's all bugs. Okay, so water temperature is one of the primary things that the state looks at when assessing the health of a waterway. And there's 3 major classifications. So cold water fisheries, or the Pennsylvania Fish and Boat Commission calls them Class A wild trout streams. These are our top-notch platinum standard waterways. And these are cold and support the survival and reproduction of salmonid species. So that means primarily brook trout, and in some waterways, brown trout, which aren't native, but are breeding in our waterways. Lower end of the standard is the warm water fisheries. So these are waterways that support the kind of pond species, so things like bass and sunfish. Important, but we're starting to see that where there is more impact of human activities, temperatures are increasing, and we're seeing more warm water fisheries than cold water fisheries. And then the middle of the pack is our trout stocked fisheries. So this is probably what we're all most familiar with. So this supports all of our warm water fishes, as well as trout that are introduced and stocked for game, but only from February 15th to July 31st. That's a lot to keep track of, but don't worry, I graphed it. Now you all understand we can move on. So on this graph, I know there's a lot going on. The solid line at the bottom is the temperature range for cold water fisheries. The hashed line, which is much higher, is that warm water fisheries range. And then there's a little dotted line that kind of scoops out the top of the curve. That's our trout stocked fishery temperature range. So this is our monthly water chemistry data at all 10 sites. The big blank spot in the middle is COVID. Forgive us. So you can see every year in the late spring or late winter and early spring, we have temperatures that reach out beyond higher than our cold water and warm water temperature recommendations. But what's really nice is in that late summer, early autumn period, we have temperatures that are staying within range of our trout stocked fishery temperature recommendations, which is great because that means there's a higher likelihood that trout that are introduced into our streams are managing to make it over the summer. What's concerning is that late winter, early spring period is when our breeding trout are most susceptible to temperature damage. So when we have temperatures that are getting really warm in January, February, March, that's when we would hope to be seeing a lot of breeding brook trout. And those small fishes are not going to make it through really warm periods. And they're too small to necessarily find refuge in cold water areas where there might be groundwater seeps coming in. Not all the time, but most of the time, this is what we're starting to see. And knowing that climate change is bringing us more mild winters, like this current winter, if you could even call it that, the long fall, we can expect to see our water temperatures tracking on the warmer side in the late spring or late winter and early spring. And predictions are that we'll have about 1 month of over 100 or over 95 degree temperature days by the year 2100, which means that there's going to be increasing temperature pressures in that late summer and early fall window that could continue to put even more stress on our species. Knowing this is important so we can start to make recommendations and changes to our land use to protect and buffer our streams from this temperature increase. So that brings us to dissolved oxygen. To bring you back to middle school biology, oxygen enters our stream 3 main ways. The first is through just contact with the atmosphere. The second is through wind and wave movement, so through riffles and incorporation of all that good air and bubbles into our waterways, and then through photosynthesis. So plants actually produce a ton of oxygen into our streams. but it's cyclical. So you'll see increases in dissolved oxygen over the course of the day as those plants are photosynthesizing, and then decreases at night when they're dormant. So it's just a cool thing. If you start looking at dissolved oxygen research, you see all sorts of interesting interactions. Here is our dissolved oxygen data. And you can see that dissolved oxygen is really high in the late winter and early spring, and then dips down throughout the summer, which might feel counterintuitive because I just told you plants produce a lot of oxygen in our water, but it's very closely related to the fact that dissolved oxygen is actually really tightly linked to water temperature. So warm water cannot hold as much oxygen as cold water can. So as the water's warm in the late summer, that oxygen level, the maximum that it can hold, starts to decrease. And hey, our data shows that too, which is always really nice. If you've ever done any data work, it's always very worrisome if your data is not following very well-known trends. So these things together are really important when we're looking at the health of sensitive species. So fish in warm water actually increase their metabolic rate. So they need more oxygen, which feels like a very cruel twist of fate that warm water does not hold very much oxygen compared to very cold water. So when you see cold water fish in the late summer, often they're lethargic, they're not really striking. They seem pretty tired, and that's because they're incredibly stressed from this warm water and low oxygen condition. So I think that brings me about to the end of my time. But the two key pieces that I really wanted to hit is that we're seeing increased water temperatures. And we know that those temperatures are going to continue to rise if we don't take action and prioritize protecting and buffering these streams from temperature pollution. And we know that summer temperatures are also going to continue to rise. So even if our goal is just to maintain our trout stocked fisheries, then we need to be cognizant of these oversummering fish and making sure that we're protecting these waterways to protect the sport. So we're gonna hold off on questions. I know I just unloaded a ton of information, some of which might have been familiar, some might have not been. But we have the state of our streams report where we looked at about a dozen more parameters and the interactions in our waterways. But for the sake of everyone's sanity, I just hit on two today. So with that, we're going to turn it over to Dr. Keller. I'm not sure where.
I wasn't sure what to talk about tonight. First time that I've presented here, so it's a little bit of everything. And you know, talking to Lauren before I came tonight, you know, what was the talk to be about? I really wanted to try and extend what Willistown has done with the state of the streams report. Talk about what it means for fish. So at the Academy of Natural Sciences over the last 25 years or so, this was just a query of our database to see the fishes that we've collected in the region. And we've had about 58 plus species. They say plus because there's some individual species, some records in our database where we didn't identify the species, but I know we may have identified a lamprey, let's say, just to genus or the family, but we know it's a species. So 58 plus species in the Darby, Crum, Ridley Creek area. That hopefully that sounds like a lot to you. Yeah, you just be like, I see trout. That's it. I don't know of these other 58 species. But I'll show you in a second. When you start to take a look at all the different groups of fishes that you can find, it's really amazing. And we're in a really you should be really grateful that you're in a really unique area where you get all these different kinds of fishes. So cold water fishes, like a brown trout, warm water fish, like we just heard, largemouth bass, anadromous fish. These are fish that migrate in from the ocean every spring. Can't wait for the shad run to get here. American shad. American eel is a catadromous fish, so it does the opposite of what American shad do. They come in, they live in fresh water, they spend their whole life here, and then they go out to the ocean to reproduce. But they're coming in right around now as well. Bay anchovy. We've collected bay anchovy in the lower portions of the Darby, probably Darby Creek is where we got that one at. Atlantic needlefish picked up. This is down in the Tinicum area. Northern snakehead, unfortunately, another invasive species in the last 20 years. And the rare species that I saw on the list, and I tried to include them over there as well. That's the list of the what came from our database, was eastern mud minnow. And so that's some other work that we do at the Academy. We're focused on looking at endangered, threatened, and candidate species. That's what they call them in Pennsylvania. And these are species that are just basically becoming rare and are kind of flagged for protection. So anadromous, real quickly, American shad. These are all from the Delaware Basin. American shad, you see some sea lamprey amicetes. Sea lamprey get about this large. They'll be coming up in the spring as well. In this region, we'll find larval lamprey. So the adults do come into these watersheds to reproduce. American eel. Here, I wanted to show the glass eel. A lot of people are familiar with the yellow phase eel on the left, your left. Glass eels are what's coming in right now into your waters. It's this time of year. Glass eels are about this long, maybe 5 centimeters. They're coming in from the ocean and they're migrating up your rivers, and streams right now. Here are some invasive species that are in the region, in the area, in Darby, probably Darby Creek in terms of flathead catfish. Currently we have a northern snakehead study going on where Darby Creek is one of the watersheds where we're finding a lot of northern snakeheads. The bay anchovy, just in case folks wanted to know what it looked like. Schooling fish. Here's the mud minnow. So I can tell you I collected this mud minnow. This was down in the Tinicum area, in a small area that's kind of between Tinicum and the airport. It's just a wetland, marshy area the only location that I know of in these areas where eastern mud minnow are found. So why do you find this variety of species, these groups? Why do you find these groups in the region? And this is where I think I'm grateful to be a fisheries biologist in this area. And that's largely because of the variety that you have in the landscape. And so in Pennsylvania, you have about 6 major provinces. And if we kind of focus in on the province or portions that we're in right here in southeastern Pennsylvania, you can see that we have a little sliver of coastal plain in yellow. That's the Atlantic coastal plain. What you have in New Jersey and the Delmarva Peninsula and down the East Coast. And then we move into the pink or purple portions, which are the Piedmont. So all those light shades of purple, it's all one. We'll just call it the Piedmont. And that's where you get into some of the hilly, higher gradient areas that we're in today. And I saw that in my drive over here from New Jersey, as I went over the bridge through that flat area at the lower ends of Ridley and Crum and came up 452 to here tonight. And so it's really some of the major drivers and where you find fish on the landscape are whether or not you're in the Piedmont or you're on the plains. Why is that? Because these are some other major factors that influence where fish occur, and that's the slope of the water, the slope of the landscape. High gradient streams, the water moves faster, so you have less deposition, you have more cobble, more rock, so you have substrates affected. And then also temperature is another factor, and so is dams and land use that human beings, how we change the landscape. But the first 3, slope, velocity, and substrate, are largely controlled by your location on the landscape, if you're in the Piedmont or if you're in the plains. So habitat matters. These are things that Willistown and part of their State of the Streams report shows you. They're measuring these things, the physiochemical environment, those water temperature and dissolved oxygen, pH, all those variables, plus the physical habitat that I just talked about with the substrate. And this creates flow and temperature regimes like riffle, run, pool kind of sequences that, well, I'm sure a lot of the anglers in the room know. You're targeting certain habitats. This happens outside of this region, and in as you move into the plains or as you move up from the Piedmont into other kinds of habitat or other parts of the landscape, there's different habitats that happen. Also just wanted to mention disturbance also shapes communities and flow regimes. And what are some of those disturbances? Large rain events. So here's a hydrograph from the Philadelphia region. This is actually from Frankfurt. I wish I should have gotten a hydrograph from one of the more local gauges. But when we see these large increases in discharge, you obviously can't go in the water. And the water looks a lot like this, very turbid, high flow. And so these are some of the common stressors that we have when you have development, like Lauren mentioned, impervious surface. Okay, when you combine that with the landscape, which is steep, and you have impervious surface, you get a lot of flooding. And so the contaminants from the land go into the water. You also have eutrophication, which means more nutrients. So any fertilizers and things that you're putting on or around your house, this runs into the water. The list is there. They all influence the biota, or what lives in the stream. And in my case, the things I care about are fish. So it influences fish. Some of the responses you get to this kind of urbanization or these kinds of development, you see fewer cold water species, more in general. I'm going to talk in very general terms right now. You see fewer cold water species. What happens when you have, for example, think to yourself, you have a parking lot and it's summertime and that parking lot is next to a cold water stream. The parking lot gets hot, it rains, the runoff goes into the water. That's the warm water going into a cold water stream. If you are a cold water fish, you don't like that. So fewer cold water fish, fewer intolerant fish, fewer intolerant species. So we know generally, biologists and environmental scientists, we've grouped animals into these categories of whether or not they're tolerant or sensitive, good indicators of water quality, and other ones that are tolerant of pollution. So we've done a little bit of homework and figured that out. So when you have fewer intolerant fishes in these urbanized areas, you have more tolerant fishes that can tolerate the flashiness, like that photo I just showed, and the turbidity. So there's certain indicators. And you can see some of the ones that you may know here: brook trout, slimy sculpin. In my opinion, this would be if you found brook trout and slimy sculpin in a stream in Pennsylvania, you're probably in one of the most pristine water bodies in the state. If you're in a headwater stream, and that's the kind of fauna that you find. If you're finding some of these other animals in a headwater stream, you're in a very polluted, very degraded stream, unfortunately. And these are all animals that live in Darby Creek and Ridley watersheds. More of what I just showed, more species, some stressors due to agriculture, a little different than more of an urbanized, but now we're talking more of an agricultural effect. High nutrients, you get some channel simplification, loss of reduction of your riparian, so you're losing the shading, you're losing the woody debris that falls into the stream and creates habitat. Low flow in the summertime, possibly intermittency where it dries up altogether. Sometimes you get an intermittent stream. This all affects the animals that can live there. We're good on time? Okay, so on that last one that I just mentioned, when we're talking about intermittency, one of the things we find is a fish like the creek chub shows up. This is a fish that's an early colonizer. So it likes to go into streams that are just formed or that recently receive rainfall. If it's a dry basin, they'll swim up to it. They're one of the first fish we find. I wanted to touch on this now real quickly. Just some hypothetical projects that might be done to try and correct some of the problems that I just talked about, or deal with some of the problems that I just talked about. And for example, this is purely hypothetical, but if you had a channelized stream that was causing flashiness, or it was causing a lot of erosion, or it had poor structural complexity, meaning you don't see the wood piles or the down trees or the habitat that is there for the wildlife, fish and wildlife. There's one solution, there's many, but one solution might be to put in a BMP that tries to reconnect that stream to the floodplain, to try and reduce the flashiness by allowing the stream to go onto the floodplain. So one of the things we find in urbanized areas, it's very channelized. So as the water increases, the water has nowhere to go downstream. It picks up speed, it picks up velocity, picks up energy. If you connect the stream to the floodplain, now the stream can go onto the floodplain, slow down, and drop that silt and sediment on the floodplain or woody debris, and it'll slow down the flow and work on these problems. That's how much I have left. Oh, that's how much I've gone. Okay, great. I'm going to skip over this these last couple slides. I'd like to show just an example of some of the fish monitoring that we do, and let me get to that. Get some assistance with getting that up. Let's see where that's at. Sorry.
That's okay.
It's a best management.
So
Sorry about that.
A BMP would be an example of putting in a bioretention basin or riparian buffers, things that are active on the landscape that can help improve water quality.
Here's some work we did with,
My name's Dave Keller, and I am a fisheries biologist at the Academy of Natural Sciences. In the fisheries department, we survey fishes to assess their distribution and abundance, and to assess the impacts of human beings on fish. Today, we are at Kirkwood Preserve on Crum Creek. We're near the headwaters of Crum Creek, which is a tributary to the Delaware River. We're about 30-40 minutes from Center City, Philadelphia. So today we had a large crew, the fisheries department, Dr. Horowitz, Paul Overbeck, Allison Stocklosa, fisheries biologist from the academy. We also had folks from the Riverkeeper and Willistown Trust, all here to survey the stream today to assess the fish community and the American eel that lives in the stream. So we're using a backpack electrofishing rig. This is a backpack that has a small power source on the back of it that we then use to put some electricity into the stream. When a little bit of electricity goes into the water, this temporarily immobilizes fish. They typically roll over and float to the surface, or are carried by the current downstream. And it's at that time that we net them and we'll place them into a bucket. And normally they revive within seconds. Not yet. Oh, something straight ahead, like 5 feet ahead of you. Floating on the surface.
They're all hiding under the stump.
Yep, we're getting a lot of fish right here, like Allison just said, under the stump. This is good fish habitat, providing some cover. One thing commonly that we deal with at this time of year is little willow leaves that drop themselves in the water, and they look just like a minnow. And we commonly net them, and
They are looking like crayfish. See something happen. Did you see it come out?
yeah, I think it went up this way. Picking up a fair number of, yeah, like kind of your lentic species, your pond species.
I feel like that's how it looked like the other side.
We're not able to get every fish, but we're getting a sample. So it's representative of what is here. Whoa. We got this guy. I think we got this last year. Look at this. Big snapping turtle. I'll tell you what, I don't want it to tear up my net. So let's see if we can get them into the shallows. Does anyone feel like picking them up? Or no?
So he came out of the root wad.
I'm gonna let him go. Anyone else wants to? All right.
It smelled like snapping turtle for a while.
Once we've gone through the stream and collected the fish, we'll then come to a location where we'll identify the fish and measure the fish, recording information on their length, noting any abnormalities or lesions or evidence of any disease. X max 3.7. No ins 3.8.
The little code we have.
No, that was a no ins at 3.8. You want them for the small board, right? Oh, okay, got you.
The impressive is why.
Shake it down.
Shake them down.
Sometimes they'll cooperate. Oh, there you go, there you go. 27.1.
One pound and a half. Doesn't work.
$72.
It looks like-
72.4.
Okay, that's. Wow. 72.4 was what we got.
We got 69 last year.
After we identify and measure the fish, we then return them to the stream. Today, we found many fish, different species of catfish, American eel, different minnow species, different sunfish species, largemouth bass, and sunfish. This work is important to assess the impacts of American eel on aquatic communities. We're hypothesizing that American eel presence has an impact or an influence on crayfish communities by preventing or serving as a type of biotic resistance against invasive crayfish species. Fish are important constituents of streams because they integrate the activities of lower level organisms that are in the stream. Algae, macroinvertebrates, and fish are generally at the higher ends of the food chain. So surveying fishes can tell us a lot about what is going on in the ecosystem.
That work was, and I'll let you say, a great example of the kind of monitoring that we do in streams, so we can gather information to assess best management practices, as someone said, these kinds of restoration work or conservation work that you'll do on the landscape. We can see how that affects the fish. Is it having an impact? And so at this point, I guess I'll pass this off to John Jackson.
I'm John Jackson. Some of you know me. We covered protected uses a little bit, so I took it out. I'm going to mostly talk about stressors. I'm not going to give you a bucket load of bugs. Those of you who know me know bugs, 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 because bugs are the only reason there are fish. That's the bottom line. You have leaves, you have algae, you have top consumers. You have a few fish that will eat leaves or algae, not all the time, not common. The go-between, whether it's for fur or feathers or fins, is going to be your macroinvertebrates, those little guys that don't have backbones. Oh, really? I didn't intentionally. That must have come across to me transfer. First thing I want to talk about today for you, though, is just remind you where we are in this battle. One of our problems is we're all aging out. So Clean Water Act, 51st anniversary, 1972, you have to remember that the people that were involved with pushing that legislation through, they were 50 years old. They're over 100 years old now. If they were 25 and starting their career, they've been retired for, say, 10 years. So we are transitioning constantly and losing that institutional memory. It's even worse when you think about this was nothing more than an amendment. The Clean Water Act isn't standalone. It's an amendment of the Federal Clean Water Pollution Control Act. Pennsylvania Clean Streams Act is even older. We have a long history, and actually Pennsylvania had some law, and I've never been able to find exactly what it was, about protecting fish from dischargers, dated 1909. Fish and Boat has it referenced. These are the three things I'm going to talk to you. I want you to walk home with. First of all, you need to know, as Lauren said, we got a lot of problem streams. We got to own it. It's not getting worse. It's kind of getting better. The thing is that I'm not going to have time to talk about it. If we were to turn back the clock 50 years, we've made some significant improvements. You need to know that it's not all negative when you see all this red lines. The third thing is polluting is so obviously easy. Our challenge here is protection and restoration. And that's where we are testing our own patience, because people want to see change and it's not easy. So we live in a wet world. This is just the blue lines for our area, and this is probably half of the blue lines, maybe less. This is what it looks like when we throw the impaired waters on. So all these red lines are for Chester, Bucks, Berks, Delco, Lancaster, agricultural, urban. You can go anywhere and find impaired water. So if you are very interested in Ridley and it's not in great shape, you have a lot of company. You don't feel picked on, it's just the way it is. Lauren showed this 27,000 miles, almost 28,000 miles of waterways in Pennsylvania. This is, just so you know, primarily based on bugs. They haven't surveyed the state for everything. They have a microinvertebrate monitoring program, 9,000 sampling sites. Here's where we're at. This is Delaware County. And I throw this up here. I'm going to apologize right now. You're going to lose the top of everything because it's Zoom. God, they won't see it here. You have Chester County over here. You have Delaware County over here. This makes talking about these watersheds a challenge. You may as well be in a different state. They are managed by different bodies. And so the availability of data is a challenge. So I'm going to deal with them separately. I can get county data. I can't get basin data, not for these small streams, not on the PA integrated report. I could get it for white clay and red clay, but I can't get it for these small streams. 1,000 miles, if you multiply that by 5,280, you've got 5 million feet of impaired waterways in Chester County alone. Good news is Lancaster's worse. If you think about them as projects at 1,000 feet in length, and how many of you done tree planting? Raise your hand, or some other restoration. 1,000 feet is a big project. We got 5,000 in Chester County to do. We're lucky to pull off 10 to 20 a year. So if you feel like we're not moving very fast, it's because relative to the challenge, we're not. They're all good projects. They're all significant projects. We just have way more than most people tell you. And that's why I'm telling you. Here's Delaware County, smaller county, 300 miles. 95% of the stream links are impaired for one reason or another. It could be primarily aquatic insects. It could be toxins in fish, so an eating thing. It could be a drinking water or recreational contact. But most of it's because the bugs don't look good. That's almost 2,000 projects just in Delaware County. Remember, these 3 watersheds we're talking about tonight, they are the big players in Delaware County. The advantage of being in Chester is we have the Chester County Water Resources Authority, and they take a lot of this data and distill it down into maps and things like this. And you go to their website and you will see the headwater of the Brandywine, and then you go to Ridley, and then to Chester, Ridley, Crum, and Darby going across the top. It gives you a chance to see these watersheds on the landscape. The other thing they do, though, is you can actually go into the new integrated report that Pennsylvania DEP has. This is a snapshot right off of their website. If you dig in, you can see the entire basin. This little blue lines here and there are showing you, in this case in Ridley, where the unimpaired waters were. Everybody else, for one reason or another, is considered impaired. Now, you ask them, what's the stressor? And you go to, again, Chester County pulls this out for me. Flow regime, pathogen, PCBs, siltation, unknown cause. Notice unknown cause, all 3. They don't really know. This is beyond rocket science, trying to figure out what's stressing a stream, because it's not simple. And you'll see this towards the end of my presentation. But what's clear to me, two things we're going to talk about tonight aren't on their list: temperature and salt. You like to talk about temperature because you like trout. What you don't think about is what would it take for the state to monitor stream temperature? You'd be thousands and thousands of sensors just in one stream, because it's patchy. You pick up heat, you're dumping heat. It's one of the hardest things to model. And salt wasn't even on their radar. Turn back the clock. So the two things that I do a bucket load of research on, temperature and salt, they don't have the resources to monitor. It's not that they don't think it's important. They just don't have the capacity. Cut them some slack, ask DEP to get a bigger budget, vote for a bigger DEP budget. That's my take home message. One of the things that we have set up with community groups like Willistown is the Delaware River Basin Sensor Network. And we're putting out some simple sensors that measure temperature, conductivity, which is salt, and then water depth. And we have a bunch of sites that I'm going to just show you a little bit of data for. And this is not easy to pull off either. These are 50 sites. We have 150 at this point. So we look for where the data are most complete. So for example, for temperature in fish, I'm going to be paying attention to summer. I want complete data for June, July, and August if I can. Right now, Willistown is running 3 sensors in Ridley and 1 sensor in Crum. These are just from the very first 2 years when we were running it. These are 39 sites. These range from really pristine things up in the Poconos all the way down to some of the most urbanized streams around. This is stream temperature. This is in Celsius, 20 degrees, call it trout habitat. It's also actually for June, July, and August happens to be the mean temperature across these sites. Now, these were not picked as trout habitat. Somewhere around in here is probably what you would expect is ambient, unmodified. Everybody else is warmer than they were 1,000 years ago, or 500 years ago, or 100 years ago. Why? Because we went from this, where the average temperature in June, July, and August in the forested sites went from 18 to over 24 down here in the urban and developed sites, 23, 22, 24. That's all thermal pollution. That's all that is. The funny thing is, when the Clean Water Act passed, the first thing we addressed was thermal pollution, because it was, to some degree, really obvious and really easy. Stick a thermometer in, power plants and dam operations. Our biggest improvements in the first 10 to 20 years of the Clean Water Act was getting rid of water that was too hot at the wrong time or too cold at the wrong time. And that had to do with operations for dams and cooling towers for power plants in manufacturers. So what causes this thermal pollution? The sources: deforestation, stream side, but also upland. You know, heat islands warm everything up. Standing water, storm water, ornamental ponds, dams that create slow areas, anything that slows down the water, runoff. Any of that time your precipitation's hitting hot surfaces, we can see spikes in the stream on a hot day with a rain event. And those spikes can be significant. Finally, effluents. Believe it or not, I can measure thermal effects of water storage ponds or sewage storage ponds, anything that just has water sitting out there warming up, and then it goes by a pipe to the stream, adds heat. The good news about heat is it can leave the stream as well as go into the stream. So you're not stuck. It's the same as opposed to DDT. You dump DDT into the stream, it stays. It doesn't go away. Heat moves and goes and comes. So for best management practices, as Lauren defined, best management practices, these are things we do to reduce the environmental stress. So stormwater ponds are a best management practice. Riparian buffers are a best management practice. Cover crops, infiltration basins, porous concrete, porous parking lots. All are best management practices. Some cases, if you were to ask me in private, I would tell you some are better than others. Some are terrible. One way of looking at it is from the heat perspective. So we've taken to starting to talk about BMPs, best management practices, but also landscape amenities. People treat these streams like they're a playground for landscapers. Some of what they do heat it up, some of what they do cools it down. So I created a list here of things that are heaters. So if you want your stream to be without a forest, everybody wants it to look like England, the pastoral England, that's a heater. That practice of maintaining that open channel is a heater. Stormwater retention ponds. Everywhere you see standing water in a stormwater pond, that's doing nothing in July and August, but dumping heat whenever there's a rain event and it overflows. And it's super hot water. Standing water wetland treatments. Everybody wants to create their wetlands, but if that hot water in that wetland, if there's standing water, pushes out during a rain event, that's nothing but hot water hitting your stream. On-stream ponds, slow-moving water. In other words, again, many of these are legacies or they're landscape amenities where somebody wants a pond in their backyard. So they do a little dam or diversion to create a pond. Every one of those is basically putting the electric heater in the stream and saying, let's warm it up. Heater BMPs appear about in the Chesapeake, anywhere 5 to 10 times more commonly than things that cool. What are cool? Buffers, shade. Shade is our best friend for thermal pollution. Upland plantings, including over impervious cover, so plant trees on parking lots, plant trees wherever. All of those are about eliminating creating a heat source in our infrastructure. Urban and agricultural infiltration. Put your stormwater back in the ground. Don't let it stand. Don't dump it back to the stream. Infiltrate, infiltrate, infiltrate. Last thing is disconnecting activities from the stream. Off-channel watering. If you're in an ag field, you don't need to have cattle that get to the stream and build infrastructure to get them to the stream. You do off-channel watering and you keep them completely off of the stream. Those are the ways of thinking about these things. When somebody comes to you guys as fishermen and say, don't you want to be partners with us on this project? You should step back and say, are we putting in heater BMPs or are we putting in cooling BMPs? And I know the Valley Forge TU guys are very well aware of this because they have fought this battle. Ornamental ponds are the enemy of Valley Creek. So we've spent a lot of time on buffers. My research has been on buffers for most of my career. So this is a study, for example, that's now almost 25 years old. Where back in '99, we took this channel and planted trees. This is what it looks like on Google Earth in 2016. The whole goal is to say, what happens if all we do is shade this channel? We don't get bulldozers in. We don't create habitat. We don't pretend like we know what's best for fish or bugs or water chemistry. We just know one thing is true. It will be better off if we can't get to it. And the livestock can't get to it. We just pretend like we're not its best friend. We did something similar, but we didn't sample it right upstream on Crum Creek. This was a partnership between Willistown and Burn Sweeney at the Stroud Center, where we did a bunch of planting back in 2014 and 2015. This is what we started with. Now, Byrne always liked to set up experiments, so you'll notice he was looking at tree survival in different techniques. So you'll see some with cardboard, some with herbicides. But the bottom line, this is what it looks like now. Look at this forest. I would guess that by year 8, it was completely covered, completely shaded. And therefore, all of the benefits that were happening were already, in terms of temperature, starting to happen within 8 years. By doing nothing more than planting trees. So when I talk about the benefits of planting trees, I get better flow, better runoff, control for erosion, cooler temperatures. Geomorphology within 20 years is exactly the same as a forested stream. Food resources Within 8 years, I've got leaves as well as algae. All of these changes, we get nutrient processing and organic matter processing. In essence, so we shade it, it stabilizes, it produces clean water, it's got a wider bed, and that makes it more efficient. All positives without ever getting out a bulldozer, without ever asking somebody, well, what should it look like? It did it on its own. So a lot of this floodplain restoration, a lot of this channel reengineering, there's actually almost no science that says it works in any positive way, and certainly not on impaired watersheds. The data are actually far more negative. So let's look at what that means. Oh, it's cranking on your maps end. So we have some big maps and voila, it's like magic. Anna, who's in the back here from Willistown, helped me with some maps. I wanted to show you what's going on in these watersheds. So these are your watersheds. Ridley, Crum, Darby. This map shows forest cover in these watersheds across the sites that they've been sampling, 19 to 35% forested. Based on green, it looks pretty good. If you got up close, you realize there's a whole lot of non-green in there. This is impervious cover, primarily roads, parking lots, but also rooftops. We can't separate those in these data sets. So these are all when we say impervious, we just mean when the rain falls on it, it can't go into the ground. It's gonna run off, go somewhere else. A lot of people talk about impervious like it's a negative. Impervious itself isn't the negative. It's what impervious causes that impairs waterways. But it's an easy measure of combining all these different degrees of development in the watershed. Oh, I'm sorry, I'm going to run slow as it cranes through these things. So then Anna was able to show me where the buffer was missing. So every one of these red lines here, the GIS layer says there's a gap. There's no buffer. And every one of these streams has essentially heaters everywhere, open spots everywhere. The trick was we didn't have time to quantify it. So then we jumped into a data set that was available that We Conserve PA had developed that actually took a little different approach, but quantified what was available. So from that data layer, we identified 262 potential buffer sites there where there was 1/4 of an acre of buffer that could be planted. It was 216 acres total, 148 sites in Ridley, 95 in Crum, 19 in Darby. It's a lot of projects, 10 a year, and you're still looking at 20 years of restoration work. Good news is you'll have a nice forest in the first project. The bad news is you won't in the last project. So there was another way of looking at it, and that is, well, how many bigger projects might there be? So 1 acre projects, there's 65 of them. 39 in Ridley, 24 in Crum, 2 in Darby. That's a little more manageable. Those are bigger projects. If you've got an acre, you're going to be putting in about 200 trees. But they're all over the place. Once again, every one of these red dots is tied to one of these larger projects. Now, it's entirely possible that if you looked at it carefully, a bunch of projects are adjacent to each other. So you could actually do the planning and pull off a lot more faster. But in the end, what this tells you, manageable. 10 a year, 6 years, you got the big holes filled. But it's also 65 yeses, 65 landowners that you have to approach, that you have to have convinced that they need to no longer think their stream should be open. But that's a problem. And fixing that problem, which we can help with, it means planting trees. And in 10 to 20 years, all these positives happen without anything else other than helping those trees survive. So let's flip Because for every spot here that's not green, there's something else. And a chunk of that is gonna be asphalt and concrete. It's going to be parking lots and roads. And around here, those of you who've heard me talk know that one of the things I've been looking at for over a decade is road salt. So this is a new updated graph. I've taken this all the way to 2022. This is road salt in metric tons, million metric tons in the United States per year. So those of you who remember your parents and grandparents, because nobody here remembers 1940. Please say yes. This wasn't a problem. Pre-1960, there were only two. I mean, we started using road salt in the 40s and 50s, but it was almost negligible. 2 million metric tons a year. By 1960, we were up to about 10, 5 times more. 1970 to 1992. In the mid-90s, suddenly it went like a rocket through the roof. We're now at 25 million metric tons of road salt per year. That's 12 times more than 1960. So we went from 5 to 12 in the last 2 to 3 decades. We are salting like crazy. That salt is not ecologically active, except as a toxin. It just washes through. So this is where it's showing up in our streams. I threw in 2 graphs here. That line is Valley Creek, Valley Forge State Park, or Valley Forge National Historic Park. The blue dots here are Brandywine Creek at Chadds Ford. We're lucky enough from the Brandywine that we have data all the way back into the 40s. So background for chloride, so this is fluoride, sodium chloride, road salt is also table salt primarily. It's just a measure of the amount of salt. So our background, our virgin forest streams around here probably had 5 to 10. And you can see it stayed pretty low. Did a bump up, leveled off, did a bump up again. At this point, we're 30 times background valley, and we're 10 times background in the Brandywine. Why the difference? Which one's built? Which one's not? It's all a function of how much we've road salted, how much we built, roads and parking lots, and then how much we salted those roads and parking lots. If I put in White Clay Creek at the Stroud Center here, our data go back to the 60s, it's down here around 12 to 15. We'll see a little spike, a winter spike in White Clay Creek is 20 to 40 milligrams per liter chloride for a month, and then it goes back down. That's another thing. None of these are winter spikes. These are not snowmelt events. These are base flow samples from throughout the year that we averaged. So where does it look for these streams around here? So these are our sensor sites. There's 50 of them. I pasted in here the Willistown data on average. I did this based on connectivity because I could grab it quickly off of the graphs. Connectivity is a very simple way to understand salt. But we now have quick ways of doing chloride also. But here's where Ridley, Crum, Darby fit among these 50 sites. Now, these were not picked by anybody but the local group that wanted to put a sensor in. We have a whole lot of sites that are below, but some that are well above what's going on in this part of where Willistown is sampling. But it's a big band, 300, it's 100 microsiemens. So what does that look like when we talk about fluoride and when we talk about causes? So Anna did some plots for me. These are chloride concentration and percent forest cover. The more forest, the less chloride. As we chop down the forest, replace it with hardscaping, the more chloride. So we're going from under 50 to over 90, almost doubling in these watersheds based solely on the land use and land cover. Let's reverse it as we increase the road and increase the parking lots Again, we're going from the 50-ish to almost 90, just by increasing the cover. This is not a big change. You know, you're going from 8 to 16, you're about doubling it. But notice how everything just lines up. That's because salt's just moving through. The only question is, can you tolerate it? Salt's easy to measure. And I talk to Pete about this all the time because Pete's got saltitis, the big way. Salt is a problem, without a doubt. Salt is probably stressing some of these streams. Remember where we started here, 50 milligrams per liter. If we were in Maryland, all of these sites that Willistown is sampling would be considered salt stressed because they draw the line at 50 milligrams per liter. Ohio does the same thing right now. It's not regulatory thresholds, they're guidance though. Whereas if you were to go to Canada, you'd have to go to 120. This science of salt is changing based on as we learn things. But remember, this is just urban runoff. So oils, metals, sealants, herbicides, insecticides, soaps, anything that's a non-point pollutant on your yard, on your driveway, all of that ends up in the waterway. And if there's any point sources, drugs, personal care products, fertilizers that make it through the sewage treatment plant, they're in our waterway too. So how do we get less salt? That's the one thing you guys can be part of. We can't go to everybody's house, but we can talk about all of our different sources of pollution. But you can talk about salt, more physical removal, muscle in machines, more calibrated attacks. Know what you're applying. These guys go out with the back of the pickup truck and apply without ever really annually or maybe even twice a season, making sure that their machine is applying what is recommended. That's if they know what's recommended. I generally don't point my finger at PennDOT. They have the best machines going. They have computers, satellites, sensors in the ground, all telling them what to do. Friction and traction, grip, tires changed, go back to 1960. Why didn't they salt? They had different ways of making travel safe. More reasonable expectations, when to travel and what speed to travel. The idea that you're doing 70 during a blizzard is an expectation we can't sustain if it requires salting. And then training. There's a lot of room for training, and with training comes hopefully lower application. So get back to my early slide, degraded streams are common. It's due to us, the choices that we make in terms of land use and water. It's nobody else, it's us. The degraded streams are common, but many have improved remarkably. Where we have data, they've improved. Last thing, polluting is easy. It's basically just denying the fact that our fingers are on everything. Protection and restoration are not so easy, but we know we can do it. We've done it in the past, we can do it in the future, but it's about changing minds and expectations, about seeing the world with a different set of glasses on and recognizing that what I thought wasn't a problem, maybe is a problem. It's the same as fixing sewage treatment plants. We made choices back in the 40s and nasty stuff went in the water. And then we fixed those. And then nasty stuff went away. And with that, I will leave you with fish food.
Thank you all so much for your attention, and a huge thank you to our specialists, Dave and John. Someone will. So now that you have a master class in restoration and water chemistry, do you have any questions? Yeah.
There's been a lot of talk about rain gardens. They've been done so that standing water.
Yeah, so rain gardens, the question is about, will rain gardens contribute to heaters?
No, rain gardens are what you want to do. What rain gardens are designed to infiltrate. You don't put up a control pipe, an overflow pipe, a standing pipe in a rain garden. It's infiltration. Rain gardens are good.
It's a great question. Thanks, Barb.
Why can't we use more limestone streets and that sort of thing to try and control salt? I know everybody wants to melt the snow and that sort of thing, but limestone is a traction unit and so forth. And using ashes. So
Well, ashes are more complicated. That's one of the things we used to do in the old days, and that's because sometimes depends on what you burn. But limestone grit is commonly used in the Commonwealth. There's nothing wrong with that. The trick in all of that is changing practices and cleaning up. Whether it's salt or limestone or whatever, people don't, they want to feel like their roads are clean. That's one reason why we don't use sand as often. We have restrictions on dust and restrictions on sediments going through the stream. And so sand got banned and salt became the solution. And then it ended up being
model local policies and procedures for mitigating road salt use. The municipality could pick up.
no.
What are we supposed to do?
There are trainings, so every municipality goes to a training, or most of them go to trainings that are run by PennDOT, Winter Academy, Snow Academy. It's had different names over time. So there's not an ordinance, but rather how to book. The trick is these things are changing. So if you went to Maryland right now, I would assume that Maryland's training right now is like their practices, and they brine almost entirely. They brine right through the blizzard. And the reason why is the brine is saturated salt that cuts right through the snow, goes to the road, and spreads out at a micron in thickness. So the next plow through doesn't remove it, just adds to it. Whereas if you lay down rock salt, next plow through just throws it into the ditch dumps the water into the ground and into the stream. So it's changing, but right now I'm not aware of any recommendation. And remember, salt or chloride outside of drinking water isn't regulated in Pennsylvania. There's a lot of discussion in Jersey right now. And in Maryland and Ohio are way ahead of both states.
Oh, oh, that's a chemistry question. Physics, yeah.
It's a strange thing about the solubility of oxygen in water. And so as the water molecules warm up, they're less able to actually absorb oxygen. But it's a defining characteristic. So it's one of the first things you learn when you are taught about the ecology of water. Is unlike your expectation for the solubility of salt or whatever. Oxygen or water is the universal solvent, but when it comes to dissolving oxygen, you don't need to warm it, you need to cool it if you want more of it. And that's why life, as we know it in water, tended to evolve in your small, cold headwater streams. Your most primitive insects are up in those areas.
When you boil water, you're bringing it to a temperature where it can no longer hold oxygen. No longer hold the oxygen.
Very simple sounding question with a very complicated answer.
pH of the stream. Yeah. Out in the stream, center of the stream. A lot of our streams are acidic.
No, I honestly don't know. I've never seen or kind of picked up on a difference that had to do with pH. So I don't know if one exists, but does pH affect oxygen in any way? I don't believe.
If it does, it's relatively minor.
Yeah, so with over the course of a day, which will correspond with increases in oxygen, but they're not necessarily a function of each other. But that is a trend that we have seen in some of our sites. We always hit all of our sampling in the same order. And we tend to see over the course of the day increases in pH and oxygen during summer months.
Just curious, how high does the pH get? Some of these streams, I know we've had some.
8 to
that
9.
have to-
What happens is photosynthesis takes the CO2 out. CO2, believe it or not, is part of the carbonate system, and you're moving the buffering capacity. Limestone to carbonate, photosynthesis is just moving the arrow. So that it's just a function. The state has started talking about on extremely productive streams having a DO pH kind of stressor. But I'm sorry, it's a minor thing compared to all the other garbage we're putting in the water. It really, I just think there are things that we should talk about. I don't measure DO unless I think there's a DO set. Don't worry about it being too high in general. The DO, I mean, White Clay Creek is a great stream. The daytime swings of pH are impressive, but I don't think it's stressing the fish. I've seen no evidence of it.
Yeah, so pH measures the number of hydrogen atoms in the water, so those free ions. And through photosynthesis, they start to get fixed, and so that causes part of the swing too. So there's a number of different biogeochemical things that are happening in the stream that causes these shifts. Part of my presentation was wildly simplified just because of time constraints. You can spend, and I have spent an entire semester with John learning about these things. So we could have a follow-up discussion around the chemistry. And there is a little more information in the state of our streams about how some of these pieces are linked together. Because it's not straightforward. And there's a lot happening that we don't have the capability to watch.
One thing to know, rainwater is acidic. Rainwater has a pH of say 5.3, something like that. That's dissolved CO2, carbon dioxide dissolved in the water, pushing it a little bit toward acidic. It's natural. And without addition of sulfates or nitrates or something like that. It's not acid rain, it's just part of the natural system.
Or one more thought into the conversation. The map that I had that showed the physiological provinces, that the underlying geology there has a lot to dictate the water chemistry that you have at any given location. So if you're running over limestone or if you're running over sand, depending on where you're at, that'll affect the pH.
Well, and one other thing, because you guys focus on limestone a lot, and Valley is as slimy as they're gonna get. People don't realize, and it's not well known, but limestone is nothing more than another salt. And the reason sodium chloride is a stressor appears to be purely a water balance challenge. It's not that the sodium chloride is toxic. It's this freshwater animal is trying to keep this salty water out of its body, and it burns up energy running the pumps over time. Calcium carbonate, limestone, can do the same thing. So when we've taken bugs from normal streams and put them in extremely limey water, their growth slows down. And if you think about the insect fauna that is normally in a real limestone stream, it's relatively simple, even if it's pristine. And my guess is because of those osmotic challenges. They don't like it super dilute. They don't like it super salty.
I didn't see Chester Creek in the data set. Is it just outside your study area or is it just?
It is, unfortunately, yeah. So we don't do any monitoring in Chester Creek at Willistown. That's not to say that we aren't interested in doing it in the future, but do you have any Enviro DIY sensors on Chester?
Yeah, on the west side of Chester, on Goose, we just did a salt survey around the borough of Westchester, which included the northern half of Chester Creek, as well as the other, Taylor Run, Black Horse Run, Plum Run. So we did about 105 sites. So we have some information now from the headwaters, the western headwaters of Chester.
And Newland Gristmill is doing some monitoring as
They have
well.
some-
Yeah, I know. I was just talking to Jess about that. So they're doing a lot, they're paying very close attention to what's happening because they do stock trout. And they're keen on making sure that they're maintaining quality water for trout to flourish. So there is data out there. We just didn't have any presented in this.
Since our watersheds are a source of drinking water for millions of people, and salt content is that it's continuing to go up. Concern to or sourcing of water streams.
Yes. So I know that in parts of Connecticut where groundwater provides a lot of drinking water, there are certain wells that have warnings that if you have hypertension or on a low salt diet, you are not supposed to drink the groundwater because it is above your daily recommendation for consumption. So right now for our surface waters, I don't think that we're hitting those levels on a regular basis, but it is a conversation that is being held. Because it is of concern that there's a chance that for certain folks, the amount of salt you're consuming just by drinking your water might be pushing you unknown closer towards an unhealthy salt consumption.
Actually, we are over the limit. In any case, there's a paper out now that was done on 3 watering tanks for aqua. And we've had people test their water at these spigots. So low sodium is really low, at 25 milligrams per liter. We have a problem in the drinking water. ERBC is paying attention right now up in the water gap. So they have, because of their special protection status, they're concerned. If they're concerned, then that means the water intakes downstream are getting, for these lowest, the drinking water standard PA style is a little harder to get to. The good news is most of our water providers are pulling out of the larger bodies. Our highest concentrations are the ones that are right next to where the salt is.
Yeah, and I can say up in our little headwaters, we had one sample day that we were out during a runoff snowmelt event, and we were hitting 250 milligrams per liter, which is where you can taste the salt in the water. So it is definitely something that we're seeing even in our low concentration of impervious during snowmelt events.
Water quality standards could help drive outreach and salt on the roads.
They tried, got shut down. EPA hasn't revisited the standard since '88. As more data comes in, it's just getting harder. And I'll be honest with you, nobody wants to be, the political pushback by saying salt's a problem is a challenge that nobody. So when I do a presentation to municipal officials, there's almost no question. Because they remember the 90s and early 2000s when people, elected officials, lost their jobs because they didn't do snow removal in the way that people expected. That spike, starting in the 90s, it's all about people. We ask for it. And the only way it's going to change is if we don't ask for it and don't pay for it. But that's about turning the barge around.
Like the long summer, the long fall that you mentioned, you expect the salinity values to be lower relative to prior years. I mean, is that a benefit that we have this?
Yeah, that was
winter? Is
that was our dream, right? That was
Is that
kind
true?
of, if we were looking for one benefit of not getting snow,
right?
Well, we sure got warnings about snow, which meant salt still went down. And so we still were seeing salt application. And part of the issue that we're seeing is that there's elevated salt levels all year. So some of our highest values are coming in July, August, and September, especially this past year when it was very dry and it was all base flow is what we were capturing. So that tells us that the salt concentrations in the soils are high enough that there is constant feeding into our waterways, which is causing that kind of long-term elevation. And for a lot of our sensitive species, when you already are stressing warm water, low oxygen, and then you throw in a contaminant like salt, it becomes more toxic at lower concentrations, which is just unfortunate, but it's what's happening. And it's all because of that osmoregulation piece, right? They're working really hard to get that salt out. And we see in freshwater mussels are some of the most susceptible to salt contamination. And I've unfortunately witnessed during a salt spike event, watching mussels come out gaping and dying in real time, because they're unable to manage that. They've got a really low internal chloride concentration, so they cannot physically hold their shells shut. So it's one of the things that I think that as the data is coming out, how much is too much changes when we increase the temperature and decrease the oxygen presence in the water. Yeah.
What species of fish should we stock? What species and size of fish should we be stocking?
Oh God. Let's see, get rid of all the non-native. So that means we get rid of brown trout, no rainbow. So we'll find some native brook trout. Now, geez, not my realm really, like the state does so much work with trout management and so forth that it's not a space that I really actually get into too much. I'm more on kind of restoring and conserving native species.
What about that?
I mean, I'd love to see, it's tricky with trout because of the competition between browns will outcompete brookies in like a medium-sized stream. But you get into a headwater stream and then brookies might be able to outcompete browns if you're in a nice small babbling brook kind of setup. You have a real small stream. So I tend to be, I guess I tend to be more promoting natives and whatnot. I think most folks don't realize that a lot of our fishes are non-native. And it was around like the late 1800s that there were a lot of introductions. So folks think largemouth bass is native, and it's not. You know, it's largemouth bass, crappie, bluegill, sunfish, smallmouth, all your black basses, a lot of your your brown trout, rainbow trout, carp, your first introduced fish. So in my mind, I'd love to see this kind of try and restore some areas or manage some areas for native species. And so you see it in the marine world, you see these freshwater conservation areas. Don't really see it in the freshwater world, but state managers that are concerned with the loss of rare species and so forth. I'd like to see them start to consider watersheds managed for natives and not for non-natives. So in some places, that could be there's game species that are native game species, but because historically there were subsistence fishermen, we would take those fish, and those fisheries couldn't keep up. So that's why we introduced your black basses and your non-game species, a lot of the non-natives we have today, for to give anglers more opportunities to fish it. Because it is a catch and release fishery now, mostly for a lot of anglers, it's an opportunity to manage some of those watersheds for natives. Because they can keep up, they can keep up with the catch and release style fishery. So I'm specifically right now thinking of a watershed up in the upper Delaware. It's called the Flat Brook. It's in New Jersey, from the Jersey side. But the thing about the Flat Brook is New Jersey stocks it with trout, but it also is got a high concentration of your very rare species in the state. And it's not a really good trout stream in my opinion. It's a very low gradient, kind of sluggish kind of system. It comes off the Kittatinnies, and the Kittatinnies support, there's some very pristine brook trout sculpin streams coming off the Kittatinnies that flow into the Flat Brook, which is in this flat valley. So in my opinion, I'd love to see you manage the Flat Brook for natives instead of managing it for brown trout, which we're trying to put in there now, like TU wants to put in there. So I mean,
Let me add something that it's going to require fishermen to admit, and fish management people to admit that for 120 plus years around here, they've done it almost all wrong. They didn't try to solve the problem. They tried to stock their way around the problem. I wouldn't be planting 20,000 trees a year for the restoration team at Stroud if the gaps were all full. You had 100 years to plant those trees, but they didn't. They didn't fix the problems. They micromanaged it and mostly stocked their way out of it. It's only now that they're starting to realize that even their stocking programs are going to fail. If trout are actually really tough. Outside of temperature, they're way tougher than most of my sensitive bugs. They're hard to kill. Mayflies are gone. Trout will be happy. I can go to these acid mine restoration sites where the pH is sitting there around 5, and there's almost no bugs in the stream. But the brook trout are happy because they can handle that low pH. That's where they evolve. And they can handle the heavy metals once it's brought down to a certain level. The problem is the management, just once they mastered hatcheries, that was the solution, and they just ran with it. Now it's changing, but slowly, because the immediate need to answer the demands. Why should I go fishing if I'm not going to catch something? Today, big, really big, lunker.
Micro fishing actually kind of, for folks that are familiar with that, that's where you're targeting minnows. I don't know if anyone realizes that they use these really small hooks and they're actually targeting some of the minnows. People just want to catch something that they never caught before, and they just like the challenge. So that's actually interesting. That's actually an interesting kind of fishing that's kind of coming up, getting bigger. Judging from the chuckles, maybe you guys just want to stick and trap. Microfishing is getting bigger.
Yeah, and target fall fish, the freshwater tarpon. They're great fighters. They're fun to catch. They're hard to catch, from what I understand. Again, not a fisher, angler. But they are a native and they're plentiful, especially in Ridley and Crum Creeks. So if you're looking for a new kind of a challenge, they get to be quite large. Yeah.
How much our lawn fertilizer salt in their base product?
Yes, so from what we've seen in our studies, and please feel free to weigh in, fertilizers are a contributor to the salt problem. So we see elevated chlorides in some cases, and this is coming out of more of the Darby Creek community science work, that is not necessarily driven by chlorides, but it's driven by something else. And usually that something else means fertilizers that are being applied right before rainstorms. So when your lawn management comes, they come on a schedule, they throw it down, even though you know it's going to rain in 2 hours, and all of that chemical deposition onto your lawn landscape is getting washed away. And lawns can also act as impervious surfaces. So particularly in new builds where there's been a lot of regrading and adjustment, that soil gets compacted and the water cannot infiltrate into that groundwater. And so what happens is you lay turf down on top of it, and grass has a really measly weak root system. The rule of thumb is that the roots grow to half the length of the blade. So if you're growing your grass out to an inch, beautifully maintained Gulf green inch long grass, that means there is a dense mat of 1/2 inch roots underneath. And if you've ever tried to grow bean sprouts, you know that that root system becomes really compact really quickly. So a number of things that can be done to offset this is don't use fertilizers. Instead, focus on, instead of using chemical fertilizers to feed the plant, feed the soil. And start planting or interplanting meadow plants. Native plants have really robust root systems that can delve deep into that compacted soil layer, start breaking it up and create areas where in your lawn, that water can start to infiltrate into the soil and back down into the groundwater, where it then is filtered and cooled and then enters the stream as base flow. The lawn conversation is a really big one and a really important thing to be thinking about, particularly as a lot of development is moving into Chester or through Chester and now into Lancaster. We're seeing these new builds popping up with HOAs recommending lawn as the primary green space. And we need to start talking about how that's going to be impacting our waterways, because not only does the chemical fertilizer act as a source of salt, but it also is increasing the eutrophication of our waterways. So when the rain, the warm summer rain is washing all that fertilizer into the water, into a stream, it's creating the perfect habitat for really rapid algae growth. And you know, if you've ever been into a creek with a lot of filamentous algae, that's usually most of what you'll see. There won't be tons of fish or tons of bugs active in those places. And the best way to combat that is cool the water and take those excess nutrients out. And the best way to take the nutrients out is don't put them on the ground in the first place. But if you are going to use them, make sure you're applying well before a rainstorm, so those plants have the opportunity to uptake those chemicals. Otherwise, your investment is just literally washing away. Great question.
There's a perspective. Keep this in mind. I'm not saying lawn fertilizer may or may not be an issue. We're probably applying per person 500 pounds of road salt a year. How much lawn fertilizer are you applying, especially if you don't have a big lawn? The amount of road salt we're applying is oppressive. I tend to tell people, take 2 houses, 3 occupants each, 1 year, they apply a pallet load of road salt for those 2 houses. Their lawn chemicals are not part of this discussion. Long and the short of it, they're just a fraction of what's going on.
It's a different suite of problems that they're contributing to in a major way.
John, when you were mentioning planting trees along streams, is a real big thing. How wide should that carrying buffer be?
Chance I'm gonna take 100 feet each side. That's what science says. If you want temperature to run close to ambient, 100 feet. If you only go to 50 feet, you're gonna be within 2 degrees. But those 2 degrees, especially with climate change, may be the difference between trout and non-trout. 2 degrees is, remember, because it's about the whole summer, not just, sometimes it's a whole summer, maybe it's that 10-day heat wave. But so where we can, where this landscape will absorb it, we're shooting for 100-foot buffers. The minimum we get funding for is 35.
Briefly about the Australian mussel that you said was basically.
New Zealand mussel, yeah. So I can hit a few of those points. So it is a problem because it only takes one, and they're teeny. So they're very easily transported on boots or equipment. And once they're introduced into waterways, I think there is a range of impacts. I don't know if you guys want to talk more about that. In some ecosystems, they will explode. So
Yeah, they'll eat it and they'll go right through the gut. So they're not all of them. So this is not, well, it's best studied out west. They changed streams and rivers in Yellowstone. This was back in the 90s. I mean, that's where that picture with the dime on is from. That's probably somebody who was working in the Yellowstone area. And the reason snails are such good consumers of algae that they have the ability to cut off much of the other food sources that fish might depend on. So fish will eat them, but it's not preferred. What they're going to do in these watersheds around here, I thought minimal, especially if it's not disturbed. Now, I saw a video though, that Fish and Boat put on one of their sites that's out by State College, and it looked like Yellowstone. The density of these guys on the rock, picking up a rock, there were hundreds. And these guys, you know what they do in your aquarium. They will eat everything. And so that's the thing. It's going to change the food web. And if they find it positive. Now, the earlier studies, when they hit Michigan trout streams, they varied from a few thousand per square meter to 50 to 100,000 per square meter. They really, I never got a good feel for what they thought was controlling, creating that patchiness. So we don't know. They've been up in the Musconetcon now for at least 5 years. There are some places that are abundant, but the last student that went looking for them didn't find any real, they found some, but not bucket loads. So I don't know. We don't know, but we do know it has the capacity to change things if they do find it the right environment.
Yeah, they have been identified in Valley Creek. They've been in there for identified in there.
Which
Let
they didn't have
your
some-
equipment dry out or sanitize it some other.
Brandywine has them. They're all around. It's gonna be hard to not carry it around.
You found Didmo or in any of your waters that you surveyed?
Only in the upper Delaware. But kind of put the blinders on with Didimo. We just do our treatments. I mean, what are you gonna do? I'm not convinced that Didimo is invasive versus some, I mean, this is what the algologists tell me. They can find Didimo in a lot of different places. The question is what causes it in some places to turn the rocks on? And that I haven't seen explained. Have you heard anything on that one?
No, I know it was mentioned. I mean, I know of a couple areas where it's supposed to be. I think it's associated with cold water, right?
Cold and
So-
low.
So, you know, for me, I encountered when we're up in the upper Delaware. I know the Route 191 bridge, I thought, like up at Hancock, New York, that area is where I'm thinking about, where it's or it occurs, but I don't think I've personally seen it in the field. We're looking for it. Yeah, it's been kind of quiet on the Didimo front for a number of years now.
In these watersheds, what's the most predominant insect that trout would be eating?
There isn't one. So it depends on the site, depends on the time of the year. It depends on the habitat you're looking at. One of the things that makes it hard to generalize about insects is whereas, say, White Clay Creek, 19 species of fish, have over 300 species of aquatic insects. We have species there now that we didn't have 50 years ago when the lab opened. It's very dynamic. So there are certain mayflies at certain times of the year. That trout might target because they're bigger based on their life history. So if you think about your hatch chart, that's just the life cycle of the insects. Hatch charts are primarily mayflies, but trust me, there's a caddisfly that goes by, a hydrocyclid or whatever, it's gonna eat them because they're opportunists and it's a big morsel. I've always been amazed that you guys can catch anything with a midge, because relatively speaking, I mean, that's just like, all right, I'll wait. That's a lot of work to get that over. But in the eyes of the fish, they clearly feel that that's worth the risk, it's worth the energy, even though it's a fraction of a mayfly, a stonefly, or a caddis.
Or at some sites a hellgrammite.
Oh, if you're lucky enough to get it, that's not fair. I mean, that's like when Burger King and say, give me one ever.
All right, any final questions? We're gonna be hanging out for a couple more minutes, so feel free to come up and chat with us. I promise we don't bite.
And we TPO live shop here.
Great, thank you all so much.